This is our first problem on directive stiffness matrix method for truss, and this is the only math we will do. For this math, the first step is to find out the degrees of freedom. For a truss member, each joint have 2 degrees of freedom. It can move laterally, it can move vertically. For the joint B, this is the same. It can go upward or downward. It can go laterally, either left side or right side. For C, same case. And we name that, let's say this is 1, this is 2, and say this is 3, this one is 4, this one is 5, and this one is 6. So we have 6 degrees of freedom. And the second step for this math is to find out the joint load matrix. So we'll find out the joint load matrix. So you can see that we have a lateral, we are assuming that there is a lateral load that is P1 at point A, and a vertical load at point A that is, let's say, P2. And for point B, the joint, we have, let's say we have a lateral force that is P2 and a vertical force that is P3 lateral, and P4 that is vertical. And at joint C, we have a lateral force P5 and a vertical force P6. So for that, we'll form a matrix. So P1, P2, P3, P4, P5, and P6. We have this matrix, and we just know the values of P3 and P4. We don't know the value of P1, P2, P5, and P6. We'll find those values later. So we don't know this value, but we know the value of P3, which is this, and the value is 2 kip, and it is going right side, and we are assuming the direction as positive. And for P4, which is a vertical one, we have a downward force of 8 kip. For that, we have a value of -8, and for P5 and P6, we don't know these values. We'll find them. Well, the next thing is to find out the displacement matrix. For displacement matrix, we name this matrix, first one as a joint load matrix. We call that P, and for displacement matrix, we call that capital U. And we have at joint A, it can move horizontally, it can move vertically. So it has two sorts of displacement. We call the lateral one as U1 and the vertical one as V2 for joint A. And for joint B, we call the lateral one U3 and vertical one V3. And for joint C, we call the lateral one we call that B4. And for joint C, we call the lateral one as U5 and the vertical one as V6. And the thing is, if you see a bit cautiously, you will find that at joint A, it is pinch supported. So a pinch support doesn't allow horizontal or vertical movement. So we can say that E1 is 0 since it cannot move horizontally, and at joint A it can move vertically also, because a pin joint will not allow a vertical movement, so that will be 0 as well. And for U3, which is this, it can actually move horizontally, because there is no support there, so it can have a horizontal movement. So we don't know the value of that, so U3 is unknown. At joint B it can move vertically, it can go a bit downward or it can go a bit upward. Since there is no restraint there, so we don't know that as well. At joint C it cannot move horizontally, it cannot move vertically, so these values will be 0. Once we have found the joint float matrix and displacement matrix, the next thing what we need is to find out the member stiffness matrix. And for that, we have a pretty elongated formula. I'll write that formula first of all. So the formula is for member stiffness matrix. Member stiffness matrix. And you will have to find this uh, in this case you have two members, so you will have two member stiffness matrix, and to four member stiffness matrix there is a formula, we'll write that. So the formula is AE over L, and it will be a 4 by 4 matrix, C squared CS, the next thing is minus C squared, and the next thing is minus CS. There is a pattern. And for here, you have CS, and the next thing is S squared. The next two terms will be minus CS minus S squared. So there is a pattern also. And the third row will be the uh, uh, quite as like as first row, but the negation sign will be opposite. So it will be minus C squared minus CS, and it will be C squared. The next thing will be CS. And for the last row it will be quite as a row 2, but the negation will be opposite, so it will be minus cs, it will be minus S squared, it will be cs, it will be S squared. Well, now the thing is, what is C, what is S? So let's look at frame AB. So it has a slope. Let's call that theta. If you take cosine theta, we call that C. If you take sine theta for member B, sorry AB, we call that S. If you take the square of that cosine theta or sine theta, we call that C squared. We call that S squared. So these are the things. And for L, it's the length of your member. Let's say you want to find out the stiffness matrix for KAB. So it will be 6 squared plus 8 squared and the root over the quantity. So the length of AB would be 10 feet, and length of BC is 10 feet. That's given directly. So we'll form stiffness matrix for KAV and KBC. Let's form them. If you look here, you'll see that the vertical distance is 8, and the horizontal distance is 6, and the hypotenuse is 10. So your for KAV, the sine theta would be the opposite arm, which is 8 divided by the hypotenuse, so it would be simply zero point 0.8. And for cosine theta it would be simply zero point 0.6, and the length is 10 feet. So you know all the values right over here. Just take the square root of zero point 0.8, you will get 0.64. and you have a constant length which is 10. If you divide 0.64 by 10, you will get 0.064. So you can easily form a 4 by 4 matrix for KAB. So for C, you just square zero point 0.6, so you'll get 0.36, and your length is 10 feet. So if you divide that, you'll get 0.036. So your first entry will be 0.036. Similarly, you will find all the entries, and it would be 0.048. Right with me, follow me. And it would be the negative signed value of the first entry, so it would be minus 0.036, and it would be minus 0.048. And the next thing would be 0.048, and the next thing would be the sine squared, which is zero point 0.8. So 0.64 divided by 10, so it would be 0.064. So it would be 0.064. You just take the negative value of the first one, so it would be minus 0.048. It would be minus 0.064. And similarly, the third row will be the same value of the first row, but the negation will be reversed. So it would be minus 0.036 minus 0.048. It would be 0.036. It would be 0.048. And the last row would be minus 0.036. Am I writing it correctly? Sorry, the last row would be as the value of second row, which is this one, and this would be 0.064, and this would be 0.048, this would be 0.064. Find the pattern and write it as first as possible, since the math is quite long. So the next thing is we'll find out the member stiffness matrix for the second member, which is BC. For BC, you have a length of 10 feet, and your sine theta would be 0, and your cos theta would be 1. So if you follow the formula, you get a value of 0.1 for the first entry. It would be 0. It would be minus 0.1. It would be minus 0. It would be 0, 0, 0, 0. The third row would be minus 0.1, 0, 0.1, 0. The last row would be 0, 0, 0, 0. Just use the formula, you'll get that. Well, if you are here, the immediate next step is to find out the structure stiffness matrix. We'll combine these two matrices to form another matrix. We call that matrix as structure stiffness matrix. How do we form that? We just take load, and then we just bring the uh, stiffness matrix for member, and we just multiply that with the u, which is our displacement matrix. So if you look carefully, we have a joint load matrix, and for that we have uh, six entries in a single column. So the matrix is p1, p1, p2, and we know the value of p3, which is 2. We know the value of p4, which is minus 8. We don't know the value of p5 and p6. So this is our p matrix. Then we need k matrix. The k matrix is quite tricky. Uh, let's zoom it a little bit. Well, so far so good. Okay, for k matrix, we'll combine this matrix and this matrix. Actually, we'll add them, but we'll not get a here you have a 4 by 4 matrix, here you have a 4 by 4 matrix, so there are two 4 by 4 matrices. Combining them will form a 6 by 6 matrix. So how do we combine that? So for the first row we'll write that as it is. For the second row of k we'll write that as it is. So let's write them. So it would be 0.036, 0.048 minus 0.036 minus 0.048, and the next two entries would be 0 and 0. There is a formula, there is a like formula type of thing. I'm not writing that, just follow me. And for the second row of k you'll write that as it is: 0.048, 0.064 minus 0.048 minus 0.06, sorry, 64, and next two entries would be 0 and 0. Well, for the third row there are some things, that is uh, these values and these values, and these two values will be added with the kv, and kvc will be added right over here. So how do we add that? You will write the first two entries from this. You write these two things as it is. So which is minus 0.036 minus 0.048. It would be minus 0.048 minus 0.064. And the next, since it is a 6 by 6 matrix, so you have another two entries in that column, another two entries in this column also. So now you will have to find these values. And look, this is a 4 by 4 matrix, the dots I have created. And in between this dots, these values and these values will be the sum of the values I have marked in black pen. So this value will be the addition of minus 0.036 added by zero point 0.1. So it would be 0.136. Am I writing this correctly? Sorry, it should be added with these values. So it should be point. Sorry, this value will be added with this value. So the value would be 0.136, 0.136, and the next value, which is this quantity, and this value would be the addition of this value and this value, which is 0.048, 0.048, and these will be replaced as it is. So it would be minus zero point 0.1 and it would be 0. And here you have this value and here you have this value, so you just add them, so you will get 0.048. And for this value you just add that with this and you will get 0.064. And the next entries will be 0 and 0, so it is 0 and 0. And for the next row, which is this, it will be placed as it is. So it would be minus zero point 0.1, it would be 0, it would be 0 0.1, it would be 0. So the next row would be this. So this is 0 0 0 0. This is a bit clumsy, but once you have done it understanding, you'll find that easy. So we have another matrix, that is U matrix. We'll write that. So for U matrix, you have E1 and V2, which is your which is 0. So 0 0. But you want to find out the value of U3, U3 and U so V4. So you need to find out U3 and V4, and you need to find you don't yeah, and U5 and B6 is 0. So you just write them. Well, what's the purpose of this matrix? Using this matrix, you will find out the unknown value of U3 and B4. How do we do that? Look carefully. We know the value of 2 and minus 8. So the thing is, how do we get them? How do we get them? How do we equalize this part of equation and this part of equation? To get 2, follow the order. Is the third value. So this U matrix will be multiplied with this third row, and the value will be equal to 2. And this U matrix will be multiplied with the fourth row. For that, you will find the value of minus 8. So you have two equations. From there you can find out the two unknown values, which is U3 and B4. We'll write that equation. If you look carefully, did I omitted anything? You have one thing, that is you have an AE right over here. So I actually forgot to write that. You have an AE which is written over here. So you have an AE over here. You have an AE over here, and you have AE over here. Eventually, it don't affect the values anyway. So how do you find out the U3 and B4 from this matrix? So these two will be equals to the multiplication of U3 and B4 with the row, third row, right? So your U3 will be multiplied with U2 will be multiplied with this value and this value. Other values will be multiplied with this 0. So your ultimate equation will be AE multiplied with 0.136, 0.136. It will be multiplied with U3, and 0.048, 0.048 will be multiplied with V4. So you have an equation. Let's say we call that first equation. To get minus 8, you have another equation, that is AE, that will be multiplied with this value and this value. Other entities will be multiplied with zeros and zeros, so they won't affect the values. So it would be 0.048 U3, and the immediate next value is 0.064, and it will be multiplied with B4. So you have your second equation. If you solve these two equations, you will get the values of your U3. If you solve these two simultaneous equation, you will find U3 value as minus 80 over AE, and B4 as, is that minus 80? Sorry, it would plus 80, and your B4 would be minus 185 over AE. So you know the unknown dokis. We call that U3 and B4 as dokis. So if you know the values of dokis, then you can find out the values of joint reaction. We want to find out the joint reaction. Let's call that P1. Let's call that P2. Let's call that P3. Sorry, P5. which is horizontal, and outward is P6. So we want to find these values. So how do we do that? If you look this equation, which is structure is stiffness matrix, in this case we don't know the value of P1, P2, P5, and P6, but and right now, solving the equation, you know the value of U3 and B4. If you place these values U3 and B4 as 80 over AE and 185 over AE, and you just multiply this column with these rows, then you can find out the values of P1, P2, P5, and P6. It is as simple as it is. So I will show a few of the maths. So if you look carefully, let's say I have to find out the value of P1. So how do I get the value of P1? So for P1, I will multiply this column with the first row. And right now, I know the value of U3 and B4. And this U3 and B4 will be multiplied with this value and this value. And other values will be multiplied with the zeros value. So they don't affect that. So I'll get P1 as minus 0.036, and U3 value, which is 80. And one thing that is, uh, here there is AE, and your U3 and B4 has a AE in lowercase. So ultimately the AE values will be cancelled out, so they won't affect the values. So I'm not writing that. So for B4, which is minus 185, it would be multiplied with minus 0.048 multiplied with 185, and it has a negation sign of minus 180. So ultimately, you will get a value of, I wrote that earlier, you will get a value of 8 kip. Similarly, for P2, you just multiply this column of E with the second row, and you will get a value of 2 kip. I'm just writing that, and you will get P3. Just multiply the U column right over here with the third row. You will get a value of P3 as, P1 was 88, P2 was, I just, P1 would be 6 kip, and P2 would be 8 kip. Just multiply that, and P3 would be 2 kip. Pardon me. And P4 would be, is that minus 8? Yeah, it looks like minus 8 kip. And your P5 would be, is that another minus 8? Yeah, another minus 8 kip. And your P6 would be 0. You just multiply your U column with with these rows. For that, you'll find the value of P1, P2, P5, and P6, and you need to multiply, find out the value of 2 and minus 2. So these things are already given, found. So now the next thing is that, you know the joint forces. You know these joint forces A, C, right over here. Let's say we're going to find out the bar forces of AB. We call that FAB. How do we find the bar forces? So for bar forces, let's say we're going to find out the bar forces of AB. For that, we have an equation that is AE over L, and there is a formula that is minus C minus S, C, and S, and it would be multiplied with, it's actually a row matrix, that is a column matrix, that is let's go at FAB. To find out the value of bar forces of AB, how do we do that? For AB, you have a displacement at A. It can go horizontally, it can go vertically. So the displacement right over here is a U1 V2, and for at point B you have a displacement of u3 and b4. So we write that. So you have u1, u2, sorry, v2 and u3, b4. So for AB matrix, we don't know the AE value, but we know the L value, which is 10, and minus C value, which is actually minus cosine theta, which has a value of minus zero point 0.6, and for sine theta, it has a minus zero point 0.8. So the next two values is zero point 0.6, zero point 0.8, and E1 and U2 actually is 0, and U3 is 80 over AE, and U B4 is minus 185 over A. You just multiply this row matrix with this column matrix, and you just multiply 80 with this value, and you just multiply this value and just add them, and eventually you will get a value of minus 10. So this is the bar force of the member AB. Similarly, you can find out the bar force of member FBC. You have the same equation. You may have a different length, different cross section, and other things. C value, S value, C value, S value will be different, and the displacement matrix would be different. Cause for member BC, you have maybe you have V3 and U3 and B4 at point B, and you have at point C you have displacement as U5 and B6. So you can find out FBC as well. Try that, and I'm writing the value. The value would be minus 8 cube. So this is all from the direct stiffness method for matrix. So one thing that is, if you have several members, let's say for three members, the structure stiffness matrix would be different. Then it would be for three members it would be a 8 by 8 matrix. So if you have more members, the stiffness matrix would be larger. So and that's the thing from this video.